Alright guys, welcome back. We're going to be solving another question from the second chapter of the Meriam textbook Dynamics, and we have a toy helicopter that is flying in a straight line at a constant speed of 4.5 meter per second. So we have a constant speed, no acceleration, and a projectile is launched vertically with an initial speed of 28 meter per second. So have the projectile right here is going to go up, and the question is asking us what horizontal distance d should be the helicopter be from the launch site S. So right here, so that the projectile is to be traveling downward when it strikes the helicopter. And we can assume the projectile travels only in vertical direction, so no movement in a horizontal. And let's just show origin x and y axis. Let's call this one our y and this one our x. So we're dealing with two different objects in here. The helicopter is going at the constant speed, and if we want to write down the equations for that, we can. So this will be our origin. So the x will be, since the helicopter is moving in x direction, so x0 plus initial velocity times t. Obviously the time for these two has to be the same, because once the helicopter gets in there, the ball is gonna be in here, so they're gonna hit each other. So we're gonna deal with the same timing for the two objects we have in here. So the x0 is gonna be 0, and our x is what we are trying to figure out the distance d in here. And the initial velocity, we have a constant velocity which is 4.5 meter per second times d. So that's what we're going to get from the helicopter. And let's move on to the projectile. So we have y is equal to y0 plus initial velocity times t, negative 1/2 of g t squared. So y0 was 0 because that's our origin, and we're going up. Our y is going to be 20. The initial velocity of the projectile is 28t, negative 9.81 divided by 2t squared. And now we have to figure out the t, and we have a quadratic equation. We can use our quadratic formula. So I'm just going to bring everything on the left side. So 9.81 divided by 2t squared, negative 28t plus 20 is equals 0. That's our a, that's our b, and that's our c. So quadratic formula, x1 and x2 will be, let's call it t1 and t2. So t1 and t2 will be negative b 28 plus or minus square root of b squared, 28 squared, negative 2 times negative 4 times a times 20 over 2 times a is going to be 9.81. So let's see what we get for t. So that's our ratio, 28 plus, let's go with the plus first, 20 squared, negative 4 times 20 times 9.81 divided by 2, and we have 9.81 in here. So the time that we're going to get the T1 is going to be 4.87. It's going to be seconds. And if we go with the -1, we just have a negative sign in here. This is going to be the second T that we have, 0.837 seconds. So we have two different times in here, and we need to figure out which one we use. And the reason we got two time is that getting to this height will be in two different time points. The first one is when the projectile is going up. So that's going to be the shorter time, which we found is 0.837 seconds. And after that, it's going to go up and come back to this point again. And that time is going to be 4.87. And that's going to be the time that you're looking for, because the question is telling us when the projectile is traveling downward when it strikes the helicopter. So that's the time that we're going to use to find the d, not the first one. So just have to multiply 4.5 by this time in the previous equation. So this is going to be the time that we're interested. So 4.5 times 4.87, and that's going to give us 21.9 meters. And the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.